Okay, hello. Hi, Team Awesome. This is Josh Crawley, and I was really wanting to show you today how to start using Mathematica. Mathematica is a program. A lot of high schools now have it on their computers because it is rather expensive program to buy individually. I want to say it's about $200 normally. But what happens is it's a really good program for math classes because it's really good for visualizing and seeing graphs and everything. Uh, it's okay, it does pretty well at number crunching, but that's not what it's geared towards. That's more, it thinks that, oh, that's mostly what a calculator is supposed to do. Let's take what a graphing calculator can do and give it more pizzazz and everything. And there's another program called MATLAB that if you're going to be an engineering major, you will use a lot, and it's better suited for exact numbers and digits, where Mathematica is better if you're looking more at a math major or more visualizing everything. So to begin, a lot of Mathematica, you can it's best to learn by trial and error. And the first thing you want to know is what kind of functions Mathematica has. And the best place to look for it is up here in Help and the Documentation Center. And the thing about the Documentation Center is you kind of type a general idea of what function or something you're looking for, anything, and you can find it pretty well, or you can go through these different sections to see all it has to offer. So in my case, I want to know, how do I do the trig function sine? So I'll just type in sine, search. Okay, here it is, the top one, sine. It's a built-in mathematical symbol, meaning this has been predetermined. The one below it here, which is a Mathematica guide, goes into details about all the different trigonometric functions and everything. So let's go here. So as you can see, here's sine. It just says type in sine, bracket, z, bracket, gives the sign of z. And it gives you some examples here of how to do it. You can kind of learn it from that. If you need a bigger scope, it can tell you more with decimals and everything. Also, the neat thing about this is that you can actually play with the examples they have. So if I want to do sine of pi over 2, and it changes and gives you that instead. It also can give you some possible issues you might have and everything. It's a good place to come if you need more help, need examples, go into real detail, and it also gives you some other related functions to look up, such as arcsine or sine inverse sine, cosine, tangent, cosecant, degree, etc., etc. This is a good thing to look for. Now, the important thing about all built-in functions, the important thing about all built-in functions in Mathematica is, as you can see, you always start them with a capital letter, and you always surround what the function is doing with brackets. So let's see, for another example, say I want to plot the graph for x squared. I will put down plot is the function, so we use capital P. Notice that it turned black because it recognizes plot as a predetermined function. Then I would put square brackets around what it is plotting. The arrow is reminding me that I haven't told it what it's plotting yet. So now so I can just put an x squared like that. Now it turns out that this is not enough for it to plot, because if I just do it, it says, oh, I didn't give it enough information inside. I only told it one argument, which in this case is the x squared. I didn't give the second argument. So I can come back here to the documentation center, type in plots, and here it is. It says that I need to also tell it what variable the function is a part of and how far it should graph, what its x minimum and x maximum. What that means is, put a comma, and I say x, comma, 0 to 2, and now plot. It gives me the graph of x squared from 0 to 2. So the 0 is the lower x value, the 2 is the higher x value. The reason why this is important for the x is it knows what the function is in terms of. For example, sometimes you have functions based on time. Then oftentimes people use t. So since it's now using t, I have to tell it to graph for t. Notice that it kind of becomes a bit of an aquamarine here and here when it recognizes that. And I'm just going to change its bounds to -2. There we go. The curly brackets are used to group a bunch of information together that goes into one argument area. So this is the everything in this curly bracket makes up the second argument of plot. So you use this if multiple things need to go as a argument. If you need multiple data in one part of an argument, you use square brackets. To explain that a bit more, say I wanted to graph two things on this plot. Say I also wanted to graph t as well. The problem is each comma separates an argument, and plot is only supposed to have two arguments. So because of that, and I want to graph both of them, since they're both here in the beginning, I want to use curly brackets to say that this is all in the first argument, and what the first argument is this is what I'm graphing. So, and to run your function, I forgot to mention this, you hold shift and hit enter return, and it graphs it. And as you can see, we have the t squared, and we have the x graph all in one place. It's really nice and everything. If you get tired of going to the documentation all the time and you know exactly what you want, there is the function $plot, and if you shift enter that will give you a detailed information about plot. Also, hitting this arrow here will take you directly to the page in the documentation center about plot. So just for another example, there it tells me about sine. Other important things that you wouldn't normally think of as a function, if you're working with radians and you want to use, you can find the symbol for pi. However, that kind of can take a while. So there is the function pi for just pi. For Euler's number, you have to use a capital E and E, like E squared, gives me E squared. Or if you want to use imaginary letter I, it is capital I. Let's see. So, say You can also declare variables in Mathematica, which is helpful. For example, I want to do set x equal to 2. I can just do that. It says, okay, I know that. So now that x is always declared as 2, if I do x squared plus 4, it gives me 8. It plugged 2 in for x and gave me the answer. Did all the simplification. Now the problem is if I want to use x for something else or as a variable name, I will have to clear it. In order to do that, I have to use the clear function, clear x. And as you can see, x is now blue, so it is cleared again. I will have to type in x equals 2 again to declare it. So to give you more information on clear, because it's a very useful function, yeah, put clear the symbols that you want to clear the values and definitions that you have declared. If you want to create your own function, that is a bit more complicated. But to do that, first you want to know what is the name of your function. Say you want your function to be little f. How you would declare it is you do f, square brackets. Commonly, a lot of people use f comma x. Why you use the underscore here after x is you're declaring that this x inside the brackets is going to be the variable f is based on. Afterwards, you will have to do colon equal sign. As you see now, x is now green, meaning it is now the variable name. So from here, if I want to declare f of x to just be x cubed minus sine of x plus pi, like that. Now as you can see, f of x is now in black. So now if I ever type f of x, it will give me this function. It did simplify it. That'd be good if I do that. Yeah. Let me try using a different variable. The reason why it changed was the property of trigonometry. I don't want to go into the details right now, but let me change this to pi over 3. Notice it's very important. Mathematica does obey the order of operations, so I don't need a parentheses around the pi over 3 because it will do the division first before the addition. So do that again. Do that again. It changed it to cosine. Just understand Mathematica is using a bunch of trigonometric identities to change everything, but understand this equation is the same as the one I typed in, so do not be alarmed. Notice though that if I just hit F, it won't do anything. It needs, because F is declared as a function. It's not been declared as a value as we had done X up here. And because of that, it will only do this if we have the bracket and a variable name. Notice that this x here is only acting in a way as a placeholder. If I did f of t, it's just going to give me the same function but with t's, or f of s. Now if I had declared what s is, say I want to make s equals 2, and now I did f of s, it will now plug in 2 into all locations of s. This is why it's important to be careful about clearing the information you have. It's important to use the clear function a lot. Let's see. Beyond that, it's very good to just use trial and error to really figure out Mathematica. A really great way to learn Mathematica, how my professor taught me how to do it when I was an undergraduate, is a website called, let me go to Safari to show you. Safari. Two. Okay, let me search. The site is called Project Euler. Euler, E-U-L-E-R. If that's just how Euler was the mathematician who discovered the value E. Anyway, if it let me. My computer's running slow because the filming takes a lot of energy. Okay, here at projecteuler.net, if we go here to problems, all these problems are really good problems to practice Mathematica on, because these problems are kind of set up so it would take a very long time to do by hand, and a calculator is not necessarily the nicest. For example, the first one. They get gradually harder as you go on. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, or 9. Sum of these multiples is 23. Find the sum of all multiples of 3 or 5 below 1,000. So this is a really good problem to use Mathematica, because really it would take forever to calculate all multiples of 3 and all multiples of 5 and then add them together. So I highly recommend, just as practice, try doing a lot of these. Beyond that, that is where I conclude my introduction to Mathematica and how good it is. In the future, I will go over how to do this in 3 dimensions and maybe do some more difficult functions. Have a good day, and thanks for watching, Team Awesome. Okay, bye.